Okay, thank you very much, Mohammed, for the very kind introduction. I hope everybody can see me now, and everybody can also see my shared screen.
Yep.
Okay, thank you very much. Yes, the talk was already introduced. This talk about the synergistic circular value chains between rural waste and urban high-tech construction materials is not the major focus of my research, but I have been working on these kinds of considerations and concepts over the course of the last 10 years, I would say. And therefore, before I come to the discussion, I would like to also acknowledge these colleagues I have been discussing with a lot over the course of the last years within research activities and other activities like Nonkololejo or Mareike, with whom I discussed a lot, or like Michael and Kola Wolle, who are research partners in several research projects, and I will also elaborate on some of our collaborations here, and also Esther and Vincent and Faudia, who are driving very important initiatives, and they gave me a lot of insights into the life of the people they are working with. But now, without much ado, I would like to come to the challenges of the 21st century. We're talking about resilience, and resilience has to fight against challenges and impacts. And I would just like to briefly elaborate on the most important challenges that I see, which is, first of all, urbanization. Then it is also habitat. We have to make sure that the growing population has a decent way of living, and people have to be connected, and the lifelines of human beings are infrastructures. But this all has an impact on our environment. And certainly we also have to discuss issues of sustainability as soon as we exploit resources. And if we take a closer look at these 5 items that I've mentioned, we will see that concrete has a prominent role in that, because it's involved in all of these items to a certain extent, because concrete is everywhere in the world. Everything we build is kind of linked to concrete construction. Some researchers found that concrete is about 50% of everything by mass that the world produces. That's a huge lot. And considering that, the 10 to 20% of carbon emissions that are being produced by concrete industry globally are relatively small, but it's still a very high number. And the other thing is it's kind of inevitable because we don't have alternatives to concrete. Any other construction material is not available at the same amounts, and mostly it would be much more environmentally polluting and produce much more carbon emissions. So instead of complaining about this huge amount of concrete, we should also consider it as a potential, because if it is 50% of everything that the world produces, it's a high leverage if we can change something there. So let's see this as a potential and try to develop concrete technologies which are more sustainable. Concrete technologies that use more sustainable cement types, better concrete types that use less cement but probably higher quality cement and concrete, and do the same but with much lower environmental impact. And then urbanization becomes a very prominent role, because all the challenges that I mentioned here are linked to urbanization. We want to build houses, we want to build infrastructures to get the cities connected with the world, but at the same time, while we are building structures, we impact on the environment. We change the environment permanently. And by changing the environment, we use resources which has an impact on sustainability. So urbanization is one of the key driving aspects we have to look at in the future. And now, since this workshop is on resilience, and resilience is much considered as a structural issue, I think it is important to also discuss what resilience can also mean. Certainly, it means structural safety. We have to take care that the structures are durable, that they withstand the loads, and so on. But at the same time, in the future, we have to take more and more care that structures, concrete structures, urban structures, are more environmentally friendly. The entire life has to be more environmentally friendly in the future. But we also have to make sure that the cities of the future are made for the people, that there are livelihoods, that there are good communication paths, that they are integrative. And this all makes out a resilient urban structure, a resilient urban environment, and certainly also our concrete structures have to make sure that these parameters are fulfilled. So the problem is that this is wishful thinking, but urban structures today often are not like that. And Therefore, we have to look at the future. Where will the urbanization processes take place in the future? And if we take a look at this figure, the red marked countries are those countries in which you find the 20 most populated cities today in the world. But if we project that to the year 2100, we can find that there is a shift and that there are only 2 regions in which the countries can be found with the 20 most populated cities in the future. And there is a very strong focus on Africa. And indeed, 13 out of the 20 most populated cities, according to this study that I've cited here, will be in Africa. And this will be led by Lagos, Kinshasa, and Dar es Salaam, with 88 million inhabitants, 83 million inhabitants, and 74 million inhabitants, respectively. So there is a dramatic development. And this certainly causes a lot of challenges, but at the same time, we can see it as a potential again. Because at the moment, from those urban structures that have been built, that will have been built until 2050, only 20% are already existing. That means 80% of the structures, of the urban structures, which will be built over the course of the next 30 years, they are yet to be built. And this is not much time, but it's a tremendous potential to build these structures more sustainably than in the past, to not avoid mistakes of people that built less sustainable structures in the past. And looking particularly at the African continent, it offers a lot of potentials because unlike the rest of the world, the per capita carbon emission, let's say the individual carbon budget, is significantly lower than in the rest of the world. And some studies say that there is an individual carbon emission budget of 2.7 tons to avoid that our temperatures increase by more than 2 degrees Celsius in the next years. And Africa is the only continent that can reach this threshold from below. All the other countries have to come down to get to this threshold. So the offsets position of Africa to be innovative, to be more sustainable, is tremendously good. But it's not only the urban areas that are growing, it's also the rural areas that are growing. At the moment, in Africa, only 40% are urban and 60% are rural, but the average annual urban growth in sub-Saharan Africa only has been 4.13% in the past 20 years. And it's not that there is an exodus from the rural areas to the urban areas, also the rural areas are growing, but the cities just grow so much faster, more than 2 times faster than the rural environments. And the reasons are very clear, because the livelihood potentials in cities are much better than in the villages. So people are typically poorer than in the cities, and there are more poor people in the cities in percent. So certainly this is a driving force for cities to grow. And certainly in the future, this will continue to happen. But this comes along with challenges. So on average, all over the African continent, about 60% of the urban population is living under very miserable conditions. In Zimbabwe, it's not that bad, but in South Sudan, it's really dramatic with 96%. And this is a majority of the urban population that are living under these conditions. And these people should probably have a voice. And in the last year, I did a workshop at the Star Kids Initiative with children from Mukuru. It's a place which in Western societies, people would probably call it a slum. And these people are collected from the streets, and Star Kids try to get them back into a good education and to mentor them and to foster their talents. And we did a workshop and we asked them, what is the city of the future? And here on the right side, you see how the children dreamt of a city of the future. This is more or less what we crafted over the course of the workshop. And one of the results was that the children were dreaming of more space, of more trees, and of more animals. And if you think about that, this resembles pretty much a rural setting rather than an urban setting. And just a couple of months ago, right before this entire corona thing started to spread all over the world, I was in Tanzania, in Bagamoyo, which is a rather rural setting, and I did a workshop with girls and young women from Bagamoyo at the Forward Step organization. They are trying to mentor young girls and young ladies. And we did a workshop on science and engineering and women in science and engineering disciplines. But I also asked them how they would dream about the environment in the near future, and it was interesting that they said they dream of short distances to services, a health infrastructure, and access to education. So this resembles pretty much like an urban setting. So this could be considered as a kind of a paradoxon, or you could also say everybody is dreaming of the greener pastures on the other side of the fence. But basically, it is not a paradoxon. You just have to consider how we can sort out this problem. One thing is to slow down the overdevelopment of already developed regions. We should also put resources into accelerating the development of the rural regions. And in order to fulfill both of these requirements, we have to think about new ways. But at the moment, there are little driving forces. We can see that in sub-Saharan Africa, the business growth and the employment growth in service was 12% and 27% respectively, while at the same time, service is a very urban business, and agriculture had a shrinkage in business of 10.9% and a shrinkage of employment by 14.16%. So there's no driving force to invest into the rural regions, while at the same time, there's a lot of driving force to invest into the urban regions. So what is required is to develop synergies between the urban growth and the rural development. And then it's getting pretty clear, because urban growth requires concrete, mainly high-performance concrete for vertical growth as well. And the entire world requires better concrete technologies, more sustainable concrete technologies. This will be to the benefit of the entire world. And what do the rural areas provide? This is a vast amount of waste from agriculture and from mining, but I will focus on the agriculture. So if we can find ways to create, I hear some voices in the background, if we can create some synergies between, or the way to get these synergies done is to develop high-performance construction materials coming from rural areas, and this will be to the mutual benefit of the rural areas and the urban areas, but at the same time, the entire world will have an advantage from this. So how can these solutions look like? At the moment, if we take a look at sustainable concrete technologies, we try to save cement as much as possible and replace it by supplementary cementitious materials. And then we try to reduce the water content as much as possible to tickle out the highest performance out of the binder in the concrete. So we want to reduce the water-cement ratio. And this is what we're doing by using chemical admixtures that manipulate the rheology, that make concrete more flowable. And then Africa becomes all of a sudden very interesting, because about 60% of the globally available unused arable land areas are in Africa. By the way, another 30% is in South America, and the rest of the world only shares 10%. So agriculture is extremely interesting in Africa and in South America. And most agricultural byproducts, the wastes of food processing, they can be converted because they contain reactive alumina and silica, like rice husk ashes, cassava peel ashes, corn cob ashes, or sugarcane bagasse ashes, and many, many more. So this can become an interesting technology. And in Africa, in most African countries, this is not a negligible resource, even though maybe on a global scale this might have a lower impact. But in specific regions like South America and like Africa, this is really interesting. But the problem certainly at the moment, typically these farm products are produced in smallholder businesses all over the continent, and the supply chains to collect them and to homogenize them and to provide them at a steady supply, they are lacking. So maybe agricultural waste ashes as a cement replacement is better suited for smallholder concrete production, or even large scale concrete production, but better to use it right in concrete production when you can collect these ashes from the neighborhoods, rather than bringing them to the cement plant and so on, which would require a lot of investment into supply chains and infrastructure. But there's a lot of more research required in this, particularly in the process technologies, as well as in the supply chains. And the other aspect that I was talking about were the chemical admixtures. And all those agricultural wastes, before they can be converted into a reactive ash, they contain often a lot of organic components, which can be converted into a chemical admixture. For example, we found out that cassava starch, other than potato starch, has a liquefying effect while it's still increasing the robustness. So here you can see the torque in a rheometer increasing with the dosage of potato starch, but you can see that the torque is decreasing with cassava starch. So the system is getting softer and better, and has a better workability. Also, acacia gum is very interesting. It even outperforms polycarboxylate ethers in plasticizing cement and concrete system. The only problem here, you can see again the torque versus the dosage, and this is a polycarboxylate ether, this is an acacia gum, but the specification is that in the beginning it is stiffening, and then only beyond a certain dosage and also at some critical water cement ratios, they start to liquefy dramatically. And we also found a gum from Central Africa which can dramatically increase the thixotropy, which you can see here. Here you can see the torques at constant shear rate and how it dramatically goes down upon shear. And these materials are so cool that you can make a concrete super liquid for a minute, and a minute later it's stiff. And if you shake it, it's getting liquid again. It's really amazing. So these polysaccharides are extremely interesting, but they're also complicated. So much of their performance depends on the hydrodynamic diameter, on the molecular mass, on the zeta potentials, and certainly also on the ions which are surrounding these polymers. And then there are a lot of influences coming from the fertilizers, from the regions, from the specific species, from the soil type, from weather and time of the harvest, and so on. So it is super complicated, but it is also super promising. So I think we have to invest much more research and developing polysaccharides that are able to replace the petrol-based chemistry, and Africa and South America are interesting places to start that and to pioneer that. So sustainable concrete has a dramatic leapfrog potential in the rural areas, and particularly in the global south, if we replace cement by bio-based wastes like the ashes of agricultural food processing. At the same time, we can develop chemical admixtures that can replace our traditional, typically petrol-based chemistry. And in order to emphasize this, I would like to give a short case study for the case of Nigeria on the use of cassava waste. Cassava is something which can be found everywhere in the world. It's the third most important starch source in the world. In other parts, it's called tapioca, mandioca, or manjok. And you can see here on the right side how the production grew from 1961 in light blue until 2014 in dark blue. In Africa, it dramatically grew. Also in Asia, it's getting higher and higher importance. In South America, it's kind of stagnating. So you can find this everywhere. And alone Nigeria produces 20% of the global cassava demand. And therefore, this is a huge resource. And what is happening today, that cassava is being harvested, and after the harvest, it's peeled. The peels typically make out something like 10 to 20% of the tuber, and then the inner part of the tuber is further processed to a food product. And what's happening? There's a lot of waste. And since these wastes cannot be digested by animals, they are typically just dumped away, where they require space, they pollute the environment, they stink, no one wants to live in this vicinity. But instead of dumping them away and giving them no further value, it would be possible to develop an organic component that helps to reduce the water in concrete. And then it could be used for co-fueling, and eventually the ashes of these cassava peels are reactive, they are pozzolanic, so they can help to replace cement in concrete. So with something which formerly had no further value chain, it's possible, only based on the waste, to produce one value chain in the chemical construction business, and another value chain in the mineral binder business. And these two value chains are not even competing, they are synergistic. And if we want to optimize this process, we can discuss different concepts. I would just like to introduce one concept which could be very interesting. So if there is agricultural waste, and this waste first of all is given to a pyrolysis step, where we can produce pyrolysis oil, pyrolysis gas, and biochar. The oil can be converted into a chemical precursor that could go into the asphalt industry, and from here to the urban construction. The biochar could either be agricultural fertilizer, but if it is promising to be a reactive product, it can also be used as an internal fuel, for example, in a vertical shaft kiln, where green bricks are converted into finally burned bricks. If there's no pyrolysis kiln, the agricultural waste could directly go into the vertical shaft kiln as an internal fuel. And then this pyrolysis gas can certainly be used to produce energy, or it could fuel the vertical shaft kiln. And then what comes out of the vertical shaft kiln, in first instance, is the burnt brick, which is going to the urban construction anyway. But secondly, this internal fuel coming from agricultural waste can be converted into a pozzolanic cement replacement, and from here go to cement and concrete business, and from here to the urban construction. So this is just one example how this can be optimized entirely. And now I would like to summarize briefly. So what's happening today, that the rural areas produce farm products and they go to the urban regions, but there's not really a lot of potential for the rural areas to grow. But if these farm products, the wastes of them, would be used and would be converted into materials, chemicals and energy, and probably also some other chemical precursors, this could create a lot of new employment perspectives, and it could produce more innovative and green urban construction materials. And this way, the urban growth can significantly contribute to the development of rural areas. But as you have seen in some of the flowcharts, this requires more than just engineering knowledge. It's not only the structural aspects, we have to think more about it. As engineers, we have to talk to a lot of different disciplines. And if we don't want to end up here, and if we want to go here, we have to develop something which I would call a conscious engineering. That means a civil engineer has to also understand a little bit about the beauty of nature, about the history of construction and vernacular techniques. Engineers have to understand markets, and also engineers have to understand the nanoscale, and they have to understand how this nanoscale impacts the global scale. We can get there, but not only by creating such a new generation of conscious engineers within the decision makers of today, but we also have to already talk to the decision makers of the future, to the students, to the school kids, and even to the smallest, to convince them that they can be the change driver for a more sustainable future and less environmentally polluting environment. And with this knowledge and with that approach, Africa and the entire global South can pioneer green construction solutions in the near future. And with that, I would like to thank you very much for your kind attention. I think I kept the time. Yeah, thank you.
Thank you very much, Wolfram. That is really interesting, and I'm sure there are some questions whenever you're ready. The first question is, you know, the urbanization is filling up all these open spaces. In your view, how can we handle this?
Well, this is certainly true. If you live in an environment which is very close to a big urban settlement, but particularly in the African continent, this is not entirely true because the population density in Africa is relatively small compared to most places in the world. So the problem is only that there are just few small urban areas where everybody comes to. But I think with the development of, let's say, medium-sized urban structures, there would be enough space, particularly in a continent like Africa, to grow without filling all the spaces, because Africa has more than enough space available. So certainly it's not beautiful if the environment is destroyed to the benefit of urban structures, but the people are here, so we cannot completely avoid. So the population of the world is growing, and the solution would be to slow down the process of mega cities, but at the same time to invest more into the development of the rural areas to make them more developed, and from there maybe to become a seed to a medium-sized urban structure, which grows together with the environment and without polluting or destroying the already existing environment.
Yeah, thank you. The next two questions are more technical. So I just wanted to know, what's the long-term effect of replacing cement with vegetable waste? I mean, we are aware of the rice husk ash, but other types of ashes you mentioned. So what are the long-term effects of the different types of agricultural waste used in
Yeah.
cement?
Well, this is certainly a tricky question, and we could discuss this for more than hours, because certainly every agricultural waste is very different. And
Yeah.
even the same kind of waste would not have the same properties whether it grows in India or whether it grows in Nigeria or whether it grows in Thailand. But in general, this has to be investigated individually based on the soil and on the species that is grown. Certainly, rice husk ashes are let's say the best possibility, but the yield of rice husk ashes is extremely low. Rice husk ashes are good because they have an enormously high amount of amorphous silica if the burning process is done in the right way. But many other ashes contain a lot of other components, so they are not as reactive as rice husk ashes. Like cassava ash, for example, or cassava peel ash is, let's say, if you replace cement for it, it does not enhance the performance of the cement, but it keeps the performance more or less stable. We will never, I do not believe that we will ever come into a situation that we have a pure agricultural ash binder. We always have to use it in synergy with the cement. So we have to take care of the pozzolanic reactivity, and there are limitations. And some materials in some regions, they have better properties, others have worse properties. So it's always a holistic process. You always have to consider who is growing this, on what kind of soil, which fertilizer is used, what happens after the process. So we need a lot of engineering to really find an answer on which is the most promising ash. So therefore, unfortunately, I have to apologize that I cannot give a clear answer. This is good, this is medium, this is bad. It really depends on many parameters.
Yeah, that's true. And this is a question from Manu. You know that there is the high organic content in plant extracts. When you use that, there is a chance of retardation. Do you have any data on that?
Well, I don't have data, but I have experiences on that. Let's say it this way. Certainly, this has an impact. But particularly if we use this two-step processing that I sketched at the end of my talk, if we use this pyrolysis step, and if we obtain the organics before, or some organic parts already before, we can already avoid many of these problems. Sometimes a small retardation is even wanted, particularly at high temperatures. So these are all problems that exist everywhere in the world, and these are all problems where it's not easy to say there's one solution to get rid of that. But I believe these are all challenges that we can solve over the course of the next years, bringing the right disciplines together, because also those established materials like fly ashes or ground granulated blast furnace slag, they need a lot of processing in advance. So even in the cement production, we invest a lot of money in homogenizing the calcium carbonate. So this is a high investment, and we have to think about that. If we always discuss the critical items, we will never proceed a step forward.
Okay, thank you. So possibly this could be the last question. So this is a question from Mr. Nandan. And he asked, nowadays the world is favoring construction of substantially vertical buildings to reduce the land usage. How far do you think the sustainable concrete may be effective in such construction, especially in terms of the strength?
Well, first of all, I do not like vertical structures, because vertical structures are always wasting a lot of material. And in the next couple of months, I think there should be a paper published in Rilem Technical Letters where I did a calculation. And the problem is, if you build a vertical structure, you always have to stack one story upon the next story. So the lower stories have to carry the sum of the higher stories. And all of a sudden, the vertical structure becomes extremely inefficient, and we waste a lot of material. So basically, it's always better, instead of building a structure like this, to just turn it around by 90%, by 90 degrees, and we save a lot of materials. But that is just the first aspect. So urban planners, where it's possible and where there's enough space, should always consider limiting the construction height. But secondly, according to all of my experiences with these materials, the structural behavior of concrete where the cement has been blended with bio-based materials is not worse. The cement properties, we can adjust the cement properties in the same way as we did it before. So I wouldn't be concerned from a structural point of view, because the binder at the end of the day has probably a different time of reaction and so on, but the material mechanical properties and the density and so on are exactly the same. So it's like blending a Portland cement with fly ash or slag.
Yeah, basically need to look at the function, the structural performance, the carbon footprint, the economy. All of these aspects need to be considered, isn't it?
That's true. That's true.
Yeah.
We have to think much more about that in the future.
Yeah, exactly. And thanks a lot for this fascinating, interesting talk. So we will continue to debate this globally. I think we possibly need to think of the old garden city concept for urban development, so that
that is interesting. Yeah.
will be addressed. Yeah.